Greetings guys, welcome to our lesson on Euclidean Geometry grade 12. Today we are paying attention to the proportionality theorems, particularly the proofs of the theorems, how to prove the proportionality theorems. This is going to be in paper 2, and we know that from our previous experience there are a number of learners who struggle a lot with paper 2, and this is one of the topics that sometimes gives problems here and there. So the proofs are the easy sections. They are the ones that can give us easy marks because they do not change. They are always like that. Please study them and study with understanding. Don't memorize things. No, study with understanding, so that even if we change the diagram, we change the numbering, we change the letters, you are still able to do the proof. So let's get on to the proofs themselves. Now, the first one that we want you to pay attention to says that a line drawn parallel to one side of a triangle divides the other two sides proportionally. So we are saying here we have a triangle ABC, and in this triangle, if we draw a line inside the triangle, and if this line is drawn in such a way that it is parallel to the third side of the triangle. So in this case, I have this triangle, then I put a line here from point D up to point E. If I put this line in such a way that it becomes parallel to the third side of the triangle, then the sides of the triangles are divided proportionally. That's what it means. So divided proportionally, we are basically looking at a situation where there is a triangle, then we draw a line inside the triangle where this line becomes parallel to one third of the triangle. Let's say this is triangle PQR. Then in this triangle, we have drawn line MN, which is parallel to line QR. Now this line, which is parallel to the third side of the triangle, divides line PQ into PM and MQ, and the line on the right hand side is divided into PN and NR. That is the division that has taken place. Now, this part of the triangle PM, if we divide PM divided by MQ, the answer that we get is exactly the same as dividing PN divided by NR. That is what the proportionality theorem says. And this is applicable only and only if there are parallel lines in the diagram. I can change this relationship and express it in a different way. You know how maths works. So let's say, for example, I've decided to divide PQ, which is the whole line, dividing by PM, which is a part of the line. Then what I do on the left side, if I follow exactly the same division on the right hand side, those two fractions are going to be equal to each other. So that will be PR divided by PN. That is the proportionality theorem. We can create equivalent fractions if there is a line inside the triangle that has been drawn parallel to one side of the triangle. I can even create more. Let's say, for example, I want to divide the line from M to Q, or QM. If I divide QM, that is one side, divided by QP, that is a fraction. If I do the same thing on the right hand side, that would be PN divided by that is Rn divided by Rp. The fractions are exactly the same. So the proportionality theorem, the main concept or the main idea says that if you have a line which is parallel to one side of the triangle, then the sides of the triangle are divided proportionally. That is basically the main idea of the proportionality theorem. The sides of the triangle are divided proportionally. Here I divided QM divided by QP, and then it must be equal to Rn divided by Rp. That is what the proportionality theorem says. Now proving it, which is very much important for examination purposes. Let's say we have this question here, given that line DE is parallel to line BC. Please take note when you are doing a proof for geometry, you need to be clear about what have they given you, what is given versus what needs to be done. So in this case, we are given that the line DE is parallel to line BC, and we want to show that the side AD divided by DB is equal to AE divided by EC. That is given information versus what you want to prove. Now, to do this proof, we have to do some construction. Now, in the top part of the diagram, in triangle ADE, you draw the height of the triangle. So I'm going to draw the height of the triangle. In mathematics, the base and the height are perpendicular to each other. So we are using the side AD, and we draw a height from point E up to the side AD. So that means AD is the base, and this line that we have just drawn is the height of the triangle. You label that one any variable of your choice. I have labeled mine H. Then in the same triangle, you draw the height again, but this time around, you must use the side from A to D to draw as the base. So that means I'm going to draw from point D a line perpendicular to line AE, and that is the height of the triangle, and label that one with a different variable. So that is the construction that you must do. So we construct a height from point E to line AD, then we construct another height from point D up to line AE in the same triangle ADA. Then after that, in the bottom part of the diagram here, we draw or we construct the diagonals of this shape. That means line from B to point E and line from D to point C. So those two diagonals. Then your construction is complete. So where did we start? We started here. This is the diagram that we have. We draw a height from point E up to point AD perpendicularly. Then we draw another one from point D up to line AE perpendicularly also. Then at the bottom here, we draw the two diagonals of this four-dimensional figure. Then your construction is complete. Now thereafter, the proof is done using the areas. We will need to go back to the video that we did on the area of the triangle if you have forgotten. But let's just quickly have a look here. Now we divide the area of the top triangle, which is triangle ADE, divided by triangle BDE. Please be clear. There are many triangles here. So notice which triangle I'm using. I have the top big outside triangle, triangle ADE, divided by the bottom one from point B, which is BDE. We divide them. So what we notice here is that in the top triangle here, AD is the height of the is the base of the triangle, and H is the height of the triangle. So the area of a triangle is half times base times height. So that means the top one is going to be half times AD, which is the base, and the height is equal to H. Then the triangle BDE, now this is an obtuse angle triangle. So the height of triangle BDE is H, and the base of the triangle is from B to D, which in other words means the two triangles ADE and triangle BDE, they are using the same height H, and their bases are on the same line. So the area of BDE is going to be half times BD times H, which is the height of the triangle. Then we simplify. Half divided by half and H divided by H will give us a fraction there, which is AD divided by BD. That is the first calculation you do. The second one, you divide the area of the same triangle, but this time around you must use a different height. So in our previous calculation we're using H as the height. In the next one we are going to use K as the height of the triangle. So if we apply half times base times height using K, then the base of the triangle will become triangle line AE, which means the area of triangle ADE is going to be half times K, which is the height, times the base AE. Then you divide by, at the bottom here, we take a triangle that is the same base as AE, which means starting from angle C, E, and D. Now, triangle CED has got the same height K as triangle ADE. So that means the area of the bottom triangle CED is going to be half times CE times K. Now the halves are divided, the K's are divided, and we get AE is equal AE divided by EC as our answer for the next division. Then after here, we need to notice something that is happening at the bottom here. This triangle is the triangle that we have used as a triangle BDE. That is the triangle there, and we have used this height H in the first calculation. Then at the same time, in our next division, we have used that triangle, which is the one I'm highlighting in green. That is this triangle here. So if you look at this diagram, the triangle that I've highlighted here and here, the two triangles are found between two parallel lines. And if two triangles are between two parallel lines, it means their height is the same, because the perpendicular distance between parallel lines is always the same. Now they are between parallel lines and they have the same base. Two triangles that are between parallel lines and having the same base always have equal areas. So we indicate that here, that okay, the area of triangle BDE and the area of triangle CED are equal. Triangle BDE and triangle CED, they have the same areas. The reason is that, I did not write the reason here, but you can write it down. The reason is that they have the same height and the same base. Now, if the area of triangle CED and area of triangle BDE are equal, it makes this fraction here and this fraction there equal to each other. So we can now conclude that the area of triangle ADE divided by the area of triangle BDE is equal to the area of triangle ADE divided by area of triangle CED. And this area in simplified form is equal to AD over BD. And this area in simplified form is equal to AE over EC. Therefore, we can make a conclusion that AD over BD is equal to AE over EC. And that completes the proof for the proportionality theorem. So yeah, this one you need to watch it slowly and try to understand it, because when you're doing it for the first time, it may be just a little bit confusing. Not very confusing, but just a little bit confusing. So what are the main ideas here? So we have a diagram in which there is a triangle on top. So that is the one part I want you to please make sure you understand. So there is a triangle like this, which is on top of the diagram. Then we have this one here. This is the height of the triangle. So that is what we have as H in the diagram. Then at the same time, there is another one going like this. So if you look at the diagram in this form, from point B up to point D, up to point A, and up to point E, you will see that this triangle this bottom one here, and that is triangle BDE. So if a triangle is obtuse angled, a triangle that is obtuse angled, the height of the triangle is indicated outside of the triangle. So the height of the triangle will be here. This is H, that is our 90-degree angle, and the base is at the bottom from this point up to that point. So if a triangle is acute angled, then the height of the triangle is inside the triangle. This will be H. So what is happening here is that we have this triangle, which is obtuse angle triangle. Therefore, the height of the triangle is outside here. That is H. At the same time, triangle ABD is an acute angle. So the height of the triangle is inside, which is also H. And that is why when you divide area of ADE and BDE here, you are going to have the same H. It's because the two triangles are sharing exactly the same height. So the half and the half and the H and the H, they will be divided to give us AD over BD. That is the concept that we are using. Then the same applies for the next two triangles. And at the bottom, we need to take notice that if two triangles are between two lines and they have the same, they are sharing the same base, those triangles have equal areas. So that means in this case, the area of this triangle and the area of this one, that is CED, and the area of triangle BDE, they are equal to each other. So given that in these fractions, the top one, the numerator is the same in both cases. If the area of the denominator and the denominator here are equal, it makes this fraction equal to that one. And that's the conclusion that we make there. And then we can conclude that AD over BD is equal to AE over EC. And this one, don't forget to write the reason. Triangle BDE and CED have same areas because they have same height and same base. That is why their areas are the same. Then your proof is complete for the proportionality theorem. The two sides which are divided into proportion are the ones given here. It means AE to D over DB is equal to AE over EC. So in terms of marks in an examination, this will be maybe 5-6 marks there, somewhere around 5 to 6 marks, depending on the examiner. It's not 100% specific that you must get this amount of marks. The examiners always determine each year how many marks to allocate to which particular section. But we're looking at roughly around 5 to 6 marks to do this proof, the proportionality theorem. The second theorem, which is examinable, that we would like us to quickly go through, is the similarity one. So the previous one was proportionality. So proportionality, you get a triangle, and then there's a line that is dividing the sides of the triangle in proportion, and the line is parallel to one side of the triangle. Now in similarity, you get two different triangles that have equal angles. So let's say here I have triangle ABC and I have triangle DEF. If it happens that the angles of these triangles are the same, that is, angle B is equal to angle E, then angle C is equal to angle F, it will follow that angle A is equal to angle D. Then these two triangles are called equiangular triangles. They are triangles that have equal angles. Now, if two triangles have equal angles, it means the two triangles are similar to each other. So we can say triangle ABC is similar to the next triangle. So triangle ABC is similar to triangle DEF. That is similarity. So the condition here that is very critical that we need to make sure we understand is that the angle at point A, the letter A, the angle at point A, and the angle at point D, the first angle here and the first angle there, those angles must be exactly the same. So the angle at point A and the angle at point D, those two are exactly the same. Then the next one, the second letter is B in my triangle, that's AB. So B is this point, the angle at B, and the second letter E, the angle at E in the next triangle, they must also be exactly the same. Now, if that happens, it follows that the two triangles are similar to each other. Now, get this. If two triangles are similar to each other, if we divide the sides of the triangles, the fractions that we get there are always equal to each other. So if you take the first letter to the second one over the first letter to the second one, that means AB divided by DE. Then you divide by the second one to the third one, that's BC, over the second one to the third one, which is EF. That's BC divided by EF. Then if you divide the outside one, which is A to C and D to F, AC divided by DF. These fractions are always equal to each other. That is the concept of similar triangles. So we start with, what is the condition for the triangles to be similar? We must have equal angles. This one is a bit involving because it involves the other theorems that we did in grade 11, from angle at center, tan cohort, in all those things. They come handy when you're doing this. But for now, let's just be clear that the angles in one triangle are equal to the angles in the next triangle. Therefore, the first triangle is similar to the next triangle. Therefore, the sides of the triangles are in the same proportion. That is what the similarity says. All right, the proof of the similarity theorem. This is also examinable, so we need to know how to do it, and with understanding, like we have already mentioned, don't memorize things, but learn them in such a way that there is understanding at the end of the day. All right, so let's have a look at this question. In triangle LMN, there's triangle LMN and triangle FGH. It is given. Remember when we did the other proofs, we said when you're doing a geometric proof, make sure you are clear about what is given and what you need to do. So here we are given that the angle at point L and the angle at point F, they are equal. The angle at point M and the angle at point G, they are equal. If these two pairs of angles are equal, it follows that the third angles are also equal to each other. That is the information we have. Now, what do we need to prove? We need to show that the line LM, which is one side of the triangle, divided by a corresponding side in the next triangle, that fraction is the same as dividing the other two sides. So that means the LM over FG equals to LN over FH. That is what we want to prove. How is the proof done? That is the main important thing. So in the two triangles, you have to do some construction. In one triangle, so I've got two triangles here, the smaller one and the bigger one. In the bigger triangle, we draw a line, label it PQ, MA, whatever you want. We draw a line in to divide the bigger triangle. But when you draw this line, in your thoughts, in your thinking, we draw this line so as to create a triangle on top here, which is equal to the separate triangle that we have. So we construct a line, we draw a line across the bigger triangle. I've labeled mine PQ, such that the top triangle that you have created by drawing this line and the triangle which is given on the side, the two triangles are equivalent to each other. After drawing that line and creating that triangle, you must prove that this top triangle and the separate triangles that are given are indeed equal to each other, and that proof is done using congruency. So we need to prove congruency. Prove that triangle FPQ and triangle LMN are congruent to each other. Now this one is a bit funny one, but let's just follow. So this is our idea. We are taking it that the top triangle that we have drawn and the triangle that is given separate here, those triangles are equal to each other. And we need to prove that using congruency. So the congruence goes like this. In triangle FPQ, please take note, FPQ is the top triangle that we have created by drawing line PQ. Then LMN is the triangle that we already given. In those two triangles, they are sharing the angle at F and the angle at L. They are equal because it is part of the given information. Then the next one, the line FP and the line LM, they are equal to each other. And the reason for this one is construction. This triangle has been constructed in such a way that the top triangle and the separate triangle are equal to each other. And we must be careful with this one. This is the only time where construction can be a reason in your geometry. Otherwise, you're gonna now have people putting their own center, right? Construction, you get 0. Construction is only here. You are not allowed to construct your own things in geometry. You can only join two existing points. So here we can use construction. The second one is the line from F to Q and the line L to N. They are also equal to each other, and the reason is construction. So we have got two sides that are equal plus an angle. We conclude that triangle FPQ is congruent to triangle FGA, and the case of congruency is a side angle side. Now, after proving congruency, we now go on to apply these angles. We have proved that this triangle and this one are equal. So remember, from our previous given information, we were told that this angle here and this angle here, they are equal to each other. Now, if this triangle and this triangle are congruent to each other, it means that this angle becomes equal to that angle, which means the angle at P and the angle at G are also going to be equal. And if these two triangles are equal to each other, it makes this line and that line parallel to each other. That is the converse of corresponding angles, because the two angles at point P and point G, if these two angles are equal to each other, then they are forming corresponding angles, which will make these two lines parallel to each other. So those are conclusions that come. Let's quickly go through that again. We have the angle at point M that we are given is equal to the angle at point G. Then after proving that this triangle and this one are congruent to each other, it follows that this angle and this one, the angle M and angle P, are equal to each other. Since M is already equal to G, then it means angle P and G are also equal. And if they are equal, then it means line PQ and line GH are parallel to each other. Now here is the interesting thing. If these two lines are parallel to each other, it means the proportionality theorem can be applied in this triangle. And that is how the proof is concluded. So from here, we now make conclusions. The angle at point P and the angle at point M. So angle P and angle M are equal to each other because the two triangles are congruent. Then after that, we know that the angle G and angle M, G and M are equal. That one is already given. So we can therefore make a conclusion that the angle at P and the angle at M and at G, these two are equal to each other. And if they are equal to each other, it means line PQ is parallel to line GH. Once we get parallel lines in a triangle, then we can apply the proportionality theorem. The side from F to P divided by F to G. Here we are taking the line from F to P divided by F to G. That is the same as F to Q divided by F to H. That is the fractions that we get from this triangle because of the proportionality theorem, since these two lines are parallel to each other. Then from there, we notice that in this fraction, the line FP, the line from F to P, and the line from L to M, they are equal to each other, since the top triangle and this triangle are congruent to each other. So in place of FP, we can have the line LM. Then in place of FQ, we can have the line LN. And that is how the proof is concluded. Therefore, LM over FG is equal to LN over FH. And that is the conclusion of the proof for the similarity theorem. So just to quickly recap, it's quite a lengthy one. It's absolutely necessary to make sure that you study it. So we start by having a triangle. This line was put there. You draw a line here, and the line is drawn in such a way that the top triangle is going to be equal to that one. Then you prove that this triangle and that triangle are congruent to each other. Then if they are congruent to each other, it follows that we can, and the congruence is proved by two sides that we have constructed and the angle that is given, that side angle side. Then if the two are congruent to each other, then we can conclude that these angles of the two triangles that are congruent are equal to each other. Then angle M and angle G are already equal. So if angle M is equal to angle P, it follows that P is also equal to G. And if P is equal to G, it follows that PQ and GH are parallel to each other. And if they are parallel to each other, then we can apply proportionality theorem to conclude our proof. That is the proof for the similarity theorem, which is the equiangular one. That's similarity. Okay, so in this video we have discussed two theorems. The first one is proportionality. These are important items. So proportionality, you get one triangle, and in that one triangle there is a line inside the triangle which is drawn parallel to one side of the triangle. Then this line which you have drawn inside divides the sides of this triangle proportionally. So let's say this one is X and this one is Y, this one is A and this one is B. Then we can say that X over Y is equal to A over B, and the reason is proportionality theorem. That's the proportionality theorem. So that's the one we said when you're proving it, you draw a height inside this top one, you draw a height inside that one as well, then you draw the diagonals at the bottom, and you do the proof by using the areas of the triangles that are created here. We have the similarity one. Now the similarity, you are given two different triangles. So one triangle is by each side, then the angles in the triangle are equal to each other. Then if they're equal to each other, they create equal fractions. That is our video, and that is our proportionality theorems for now.